A matrix is a rectangular array of variables or constants in horizontal rows and vertical columns. A matrix can be described by its dimensions. A matrix with m rows and n columns is a m by n matrix. State the dimensions of each matrix, then find the value of each element. You count rows first, then columns. So A, you have 2 rows and 2 columns. So A is a 2 by 2 matrix. The value of the element A sub 21, you go to the second row in the first column. Second row, first column, the element that's there is 2. B, there's 1 row and 3 columns, 1 by 3. First row, first column, first row, first column, the element there is 3. So what would be the dimension of C? Great, 2 by 3. And what is on the third row? Second column, DNE, exactly. There's not a third row, so it will be does not exist. D is a 1 by 1. A sub 1, 1 is 4. In order to add or subtract matrices, the matrices must be the exact same size, must have the same dimensions. So for example, A, both are 2 by 2, so we can simply subtract 8 minus a negative 4. 7 minus 3. Negative 10 minus 2. Negative 6 minus negative 12 is positive 6. Adding and subtracting is very easy. Remember, the matrices must be the same dimensions. Number 2, they are the same dimensions, so you can add 6 plus negative 4, negative 5 plus 3, 9 plus 2, negative 3 plus 6, and so forth. See, the matrices are not the same dimensions, so the direction says to write impossible. D, we're doing scalar multiplication. It's just like the distributive property. Multiply each element in the matrix by 6. Six times 2, 6 times negative 5, 6 times 3, 6 times 0, and so forth. Multiplying matrices, you can multiply 2 matrices if and only if the number of columns in the first matrix is equal to the number of rows in the second matrix. If that is not true, you cannot multiply the matrices. Here we have a 2 by 2 and a 2 by 2. So you look at your 2 inner numbers. These 2 inner numbers must match. If they are the same, you can multiply them. That's the number of columns in the first equals the number of rows in the second. They match, so you multiply row times column. So that setup will be 4 times 3 plus 1 times 0. Then the first row times the second column. 4 times 4 times 0 plus 1 times 3. All right, then we move to the second row times the first column. Negative 2 times 3 plus 3 times 0. second row, second column, negative 2 times 0 plus 3 times 3. Clean it up for your answer. Begin. All right, here, a 2 by 2 and a 2 by 2. Check your two inner numbers. They match, so you can multiply. I'm going to give you a second to try to multiply example F. You may pause the video. Okay, did you get negative 3, negative 2? 234? Great. All right, let's continue on. The determinant of a matrix. To find the determinant of a matrix, you simply multiply your A times your D, then subtract your B times your C. So it's just cross multiplying for a 2 by 2 matrix. So here we have 6 times 5, 30, minus 3 times negative 8 is negative 24. 30 minus a negative 24 is 54. Negative 8 times 1 minus 3 times 2, 6. I guess that's negative 14. For 3 by 3, the first thing you want to do is copy the matrix over neatly. Duplicate column 1 and 2 at the end of the matrix. Now we're going to start at our very first element in a matrix, and we're going to make 3 diagonals going down to the right. On each diagonal, you should pick up 3 numbers. And to the right, so these are positive. And then you make 3 diagonals, start at your last element on the first row. To the left. Since we're going to the left, these diagonals will have a negative in front. All right, you're going to multiply your diagonals. So we're going to start going in the positive direction. You multiply the numbers on the diagonals. So 1 times 2 times 4, 8, plus 3 times 1 times 3, 9, plus 1 times 2 times 1, 2. And then the other way. You subtract these diagonals. 3 times 2 times 1, 6. Minus 1 times 1 times 1. Minus 4 times 2 times 3. And simplify, and you end up with the determinant being negative 12. Pause the video and try D. Okay, next we're going to look at how to find the inverse of a matrix. To find the inverse of a matrix, the first thing you want to do is find the determinant of that matrix. So you do 1 times 0 minus 1 times 0, and we get 0. If the determinant equals 0, the inverse does not exist. So the inverse on example A would be DNE, does not exist. Example B, determinant first. 3 times negative 8, negative 24. Minus 6 times 4, 24. That's negative 48. So to find the inverse, you put 1 over your determinant. You swap your A and your D. Swap these two numbers. So negative 8 comes here and 3 comes here. And then you change your signs on B and C. If it's negative, change it to positive. If it's positive, change it to negative. So it will be negative 6 and then a negative 4. And then simply multiply, doing scalar multiplication. It's like the distributive property. So negative 1 over 48 times negative 8, 1 over 6. Negative 1 over 48 times negative 6, 1 over 8. Negative 1 over 48 times negative 4, 1 over 12. 1 over negative 1 over 48 times 3, negative 1 over 16. That's the inverse. And we're going to use the inverse of a matrix to solve systems of equations. To do that, first you write out your matrices. So our first matrices is called a coefficient matrix. That is the numbers in front of your variables here. So in front of x we have 4, in front of this x 6, y is negative 2 and 4. This is called your coefficient matrix. And then we have the variable matrix. What variables do we have in the problems? The systems, x and y. And then we have the constant matrix. That's the right-hand side of your equations. 22, negative 2, the two constants there. So to solve a system using inverse matrices, you take your coefficient matrix and you find the inverse of it. So find the inverse. So to find the inverse, you know we do the determinant first. So we have 16 minus negative 12. It's 28. So 1 over 28. Swap your A and D. 4 and 4 is swapped. Change the signs on B and C. So negative 2 becomes a positive 2. Positive 6 becomes a negative 6. And then you multiply it out. 1 over 7. I'm reducing 1 over 14. Negative 3 over 14. And 1 over 7. Once you have the inverse, you take the constant matrix and multiply it by the inverse matrix. So I'm going to take my 22, negative 2. Remember, you multiply row times column. So I have 1 over 7 times 22 plus 1 over 14 times negative 2. Row times column. Negative 3 over 14 times 22 plus 1 over 7 times negative 2. And you simplify all of that. You can punch all of this in your calculator if you like, or you can do it on hand. You get 3, you simplify your top row, and your bottom row, negative 5. So the solution to this system of equations would be 3, negative 5.